Hello everyone. As our material becomes a little bit more challenging, I wanted to give us some quick tutorials, some quick online tutorials that when you're doing your homework or you're studying for an assessment that you're like, wait, what do I do? That you have a place to go and check it out. So this first one will be on hypothesis testing. And we're just gonna review the content that we talked about in class. So it's gonna be a little bit more condensed, but it'll have some of those tools that are really needed to be able to really be successful on those homeworks and in studying for those assessments. So, as a reminder, our steps for the hypothesis test, the first thing that we're going to do is state our hypotheses. This is both our research and our null hypothesis, and we're going to state those with the populations in mind. So we're going to talk about the populations in there. We're going to figure out what are we comparing it to, right? We have this sample. We're going to collect this sample data. What are we comparing it to? That's step 2. What are those characteristics of the comparison distribution? Step 3, what's our criterion for a decision, right? This is null hypothesis testing. What's the criterion? When do we get to reject the null and when don't we get to reject the null? And remember, we want to do steps 1 through 3 before we collect data, before we compute sample statistics, so that we're not inviting any bias into our research, that we can really maintain that level of objectivity that we need so that people understand that we might be right this time, but we might have been wrong next time, right? And that level of objectivity is really, really important. Step 4 will be collect that data, which we're not doing. We'll give you that sample data and compute our sample statistics. Then we're just going to figure out, okay, we've got our sample statistics. So step 5 is just put that sample statistic on that comparison distribution that you set in step 2. So step 2 is essentially draw the distribution, say what kind of a distribution it is. Step 3 is put those cutoffs on that distribution. And step 5 is put your sample statistic on that distribution. And once you have all of those pieces together, then it'll be really easy to do step 6 and make a decision and decide whether to reject the null or not. So looking at those one by one, again, we're going to restate those research and null hypothesis, and we're going to talk about them in terms of the population. A null hypothesis, no matter what kind of hypothesis testing we're doing, will always be the idea that there's no effect. That whatever we're looking at, whatever the interest is, whatever that difference is, that it's not there, that there's nothing happening, right? This is that wah-wah that we talked about in class, right? So you can kind of use this as a template for writing a null hypothesis. Population 1, whatever population 1 is, fill in the blank there, will not be different than population 2. Fill in the blank there. Who is population 2? On whatever the treatment is, fill in the blank there. So just make sure you're talking about those pieces of it so that we know what we're trying to generalize to. Those are important. And we want to make sure we include that mathematical representation so we know kind of what this looks like in terms of the math, right? What this looks like in terms of the numbers. And in this situation, we'd say mu1 is equal to mu2 because there's not going to be a difference. We could also write that as population 1, whatever they are, will be the same as population 2, whatever they are, on whatever the treatment is, right? So these are kind of templates that you can use and kind of fill in the blank with that information about who's the population and what we're looking at the comparison for. That alternative hypothesis or that research hypothesis says that there is a change, there is a difference, there is a relationship. Those could be 2 different kinds of relationships, right? We could have that non-directional relationship that's just that there's a difference, right? So population 1 will be different than population 2 on whatever the treatment is, right? And so here we would say that those 2 population means are not equal to each other because there's a difference there. So again, this is just ahead of time. What are we looking for? What are we hoping to find support for? The alternative hypothesis. And what are we trying to reject? The null hypothesis. If you had a directional example, same thing, fill in the blank. Population 1 will be more, less, happier, sadder, whatever the case may be on whatever that treatment is than population 2. Make sure this one gets a little bit dicier. We got to make sure we got our less than or greater than figured out. Remember, less than is the one that kind of points, the arrow always points to the smaller value. So if it's, population 1 will be less happy than population 2. That would be that first example. If that second example would be population 1 will be more whatever than population 2. So make sure you're thinking about that direction in those examples. Step 2 is just figuring out what we're comparing it to. We have this sample, we're trying to generalize to a larger population. We can't generalize to that population because we don't have everything figured out about that population. We have a sample mean, and that's a population of individuals. So we need an in-between to be able to make that comparison. And for a z-test, that in-between is that distribution of sample means. So that will always be your answer for a z-test. It will be a distribution of sample means. You just need to tell me what size that sample was. So in one of our examples in class, that sample size was 4, right? So then you would put your, or 5, so you put your sample size as 5. Whatever that n is your sample size. So this, I really recommend going ahead and drawing that distribution, because we're in step 3 and in step 5, we're gonna want that to be able to make that distinction of whether we're rejecting or not. You do not have to draw that distribution, but it does make kind of making those decisions and figuring out where everything lines up a lot easier. So I do really recommend drawing that. You can just call it a distribution of sample means and then tell us what that sample size is. For step 3, what are the criterion for our decision, right? Again, those conventional levels of significance are 0.05 or 0.01. We have gone ahead and looked up in the Z table what those probabilities are. So you don't have to use your Z tables for this, because the beauty of a Z table is because it is a standard distribution, it doesn't change. And so 5% is always negative 0.64 or positive 0.64 for a one-tailed test, or negative 1.96 and positive 1.96 for a two-tailed test. Notice in that one-tailed test it says or, right? Because it's a directional hypothesis. So we're either looking at the top or we're looking at the bottom. We're not looking at both. In a two-tailed test, we're going to be looking at both. And so that's why those values will be a little bit different. If for some reason I have left off the probability that I ask you for, that probability of the of making a decision when the null hypothesis is true when it's not true, then what I want you to do is just pick it at 0.05. That is the highest probability that we're willing to accept. So if there's not information included about what that criterion for the decision should be, if I didn't give that to you ahead of time, then you just put it at 0.05. And again, this table is also in your lecture outline, so you have access to that. You can look these things up in your Z tables in the back of your book. You are more than welcome to do that, but you'll see that they're the same, so we've given you a little shortcut here. Okay, so again, I would go ahead and mark those points on that comparison distribution, that distribution of sample means, because that will make making that decision later easier. Step 4 is kind of where the actual statistics is happening. We have already given you your data, so you won't need to collect any data. We're just needing to compute that sample statistic. For z-test, our sample statistic is a z-score. This part will change some when we do different tests, but the other pieces will stay the same. And so for this z-score, we're going to use that z formula for sample means. And so what we do is we just plug in that information that we've already given to you, right? You'll have been given the population mean and the sample mean and the standard error. We just plug those into that formula and we calculate that ratio, right? Remember that top part of it is going to be that effect, and that bottom part, that denominator, is looking at that error. What's the error that we expect? That kind of signal to noise, the effect to error kind of ratio. So we'll just plug those in. On your homework, there's some that are going to be the exact same sample means, as exact same standard error, and the exact same population mean again and again and again. And that's just because we're practicing kind of what kind of decisions we would make in these different situations. So it's just a practice. Their numbers are really nice and easy because we're just trying to figure out this hypothesis testing part. For step 5, we're going to put our sample value that we just calculated in step 4 on our distribution. So we already had our distribution from step 2. We already had our criterion for our distribution from step 3. I went ahead here and said this is a two-tailed test set at 0.05. Note that these numbers will be different if we're doing a one-tailed test or if we're doing a different p-value. And so again, we'll put that sample score on there. That sample score, remember the middle of that distribution, this is a standard distribution, so that middle of that distribution, that mean of that distribution is always 0. And so then we can, if we know where 0 is and we know where our cutoff values are, we can figure out where on that number line does our z-score go. Does it go here? Does it go here? Where does that z-score go? We can just go ahead and put that on there. And then that last part is to make a decision, right? We've put our z-score on there. If that z-score is in that critical region, then we're able to reject the null and support our research hypothesis. Yay, we did it, right? This is what we're hoping for. But oftentimes that value may not be in that critical region. That value may not be might not be an extreme score. It may be a very high probability that the null hypothesis is true. And so in that case, we would fail to reject the null. Remember, we never accept the null because just because there's a high probability that the null is true doesn't mean the null is actually true. So we just fail to reject it. And so here we're rejecting the null. We're saying it's not likely that it's true. Here we're going to fail to reject the null because we can't say there's a high probability that it could be true. That doesn't mean it is true, but it could be true. And so that's where we'll make those kind of distinctions. So those are our 6 steps. Those are the steps that you're required to do. Again, your homework kind of breaks it up in different parts. There's parts that are just asking you to work on those hypotheses and to look at what kind of tests you would do. There's another part that's just looking at the decision-making part. And then there's another part where we kind of put all those pieces together and make these decisions in this 6-step format. So again, I encourage you to kind of use this tutorial to kind of walk you through those different kinds of things. Just as a reminder, for hypothesis testing, those one versus two-tailed tests, if we have a hypothesis that has a direction in it, it's more than, it's less than, it's any of these kinds of things, it's a one-tailed test. And if we have a hypothesis that doesn't have a direction, there just is a difference, then it's going to be a two-tailed test. So examples could be, again, the research hypothesis says a sample baby will walk earlier. Earlier is telling us that there's a direction. It's less than, right? So that would be a one-tailed test, and it would be a one-tailed test looking at the bottom, right? The bottom of that distribution. It'd be a low. That's where our critical region is going to be because we're thinking it's going to be less than than our population 2. Research hypothesis, the millionaire will be happier, right? These were our examples from class. This would be a one-tailed high because we're thinking we're going to have more happiness, right? So we'll be looking at the top 10s of that. Again, those one-tailed tests are specifying a direction. We're either cutting off the information on the top side, the right side, the high side. We think something's going to be more than. Or we could be cutting off that distribution on the low side, the left side, thinking that something's going to be less than. In those two-tailed tests, we're cutting off both tails of the distribution. There is not a direction. There just says that there will be a difference between those. And so we'll cut off both tails of that distribution and look in both of those. So I hope this video was helpful to really kind of walk you through this again, that quick tutorial of, wait, what did she say? What am I supposed to do? I do understand that this, the first time you especially get a lot of this content, it is a little bit hard to kind of sometimes make those mental leaps. And so I want to make sure that you have the support you need to really be successful in the homeworks and the assessment. So these quick tutorials will start up with Z-scores and we will use them moving forward. Thanks so much, everyone.